Hi, in this video, I will be showing you problem number 19 of chapter 2 section 4 from the practice exam. Prove the statement using epsilon delta definition of a limit. Limit as x approaching 1, 10 plus 2x over 3 equal to 4. We'll start off with the definition of epsilon delta for limit. Given an epsilon positive, to find a delta positive such that if 0 less than absolute x minus a less than delta, then absolute fx minus L would be less than epsilon. In the problem that is stated here, we have to figure out what this value a is and what this value L is. In this problem, x is approaching 1, so a equal to 1, and then the limit value is equal to 4, so L equal to 4. So if we modify the same definition for our problem, it's given an epsilon positive, we have to find a delta positive such that if 0 less than absolute x minus 1 is less than delta, I'm replacing a with 1, then fx minus L. Fx is in this problem is this 10 plus 2x over 3. So it is 10 plus 2x over 3. That's for fx minus L. L equal to 4 minus 4 less than epsilon. But let's examine what this statement here means. So absolute 10 plus 2x over 3 minus 4 less than epsilon implies an implied by 10x plus 2x minus 3 times 4. That will be a 12 over 3 less than epsilon, which implies an implied by absolute 10, that's not a 10x, 10, minus 12. So we'll have a 2x minus 2, 2x minus 2 over 3 is less than epsilon, which implies an implied by, I can pull out common factor the 2. So 2 times absolute x minus 1 over 3 is less than epsilon, which implies absolute x minus 1 is less than 3 epsilon over 2. We are pretty much multiplying both sides by the reciprocal of 2 over 3, which is 3 over 2. So we started off by saying we have to find a delta such that when absolute x minus 1 is less than delta, then absolute fx minus L is less than epsilon. So this delta should be chosen as this one. So if you choose delta to be smaller than or equal to 3 epsilon over 2, then absolute x minus 1 would be less than delta, which would mean this, and then we can actually retrace the steps. So we are proving both the necessary and sufficient condition here because we are using the symbol implies and implied by. Otherwise, we can do also one way, and then we can also retrace the steps to show the reverse is also true. Hope this video helps.